Okay, I'm recording already. Okay. So, okay, let me summarize a bit. Okay, what we have learned. Let me see whether I've recorded the sound. Okay, definitely I'm recording the sound also. Okay, so yeah, we okay, so we have already learned how to resolve the vector into two components. Okay, for example, okay, I have a vector this way. Let's say this is a force equal to 10 Newton. Hey, let's say we have angle theta equal to 30 degree. Okay, so okay, so x and y axis over here. Okay, so to resolve the vector, remember we use the mantra. We can say it is our mantra. Adjacent to the angle theta, we use adjacent always cos theta, isn't it? Adjacent to the angle. Like for example, this component. This component, it is adjacent to the angle theta. So it is using cos theta. So this is fx equal to 10 cos 30 degree. Okay, and then if we have opposite to the angle, we use sine theta. Okay, opposite to the angle. For example, we have another component here. This is the y component. So this force y, this Fy is actually opposite to the angle. Yeah, because you can put the Fy over here. Okay, opposite to the angle theta. So opposite one we use sine theta. Okay, so this one is 10 sine 30 degree. Okay, both of these are positive, yeah, because they are in a positive direction. So they are actually all positive value, yeah. Unless if the vector is going to the left or going downward, then only you have negative, yeah, if going to the left or downward. Okay, but both of these are positive. Okay, let us calculate first, yeah, this value. Okay, let me calculate this value first. Okay, let me find the value. Okay, so 10 cos 30, 10 cos 30, so what is 10 cos 30? So wait a second. Okay, it's 8.66, isn't it, class? 8.66 Newton. Okay, and if 10 sine 30 is 5 Newton. Correct, class? Okay, so this is how we resolve into two vector lah. Okay, but this is resolving. Okay, we resolve the vector. It resolve into x and y. Let's say I want to combine these two. This actually, remember, this is a right angle triangle. Okay, to find back, yeah, to combine this fx and fy back to f, we just use Pythagoras theorem. Understand? We just use Pythagoras theorem. So the magnitude of f actually is surd or square root fx square plus fy square. Okay, you try and see if you 8.66 square plus 5 square, what do you get, class? What do you get? 8.66 square plus 5 square, and then surd the answer. See, I get 9.99, which is 9.9998 Newton. So which is 10 Newton again, isn't it, class? Okay, so we can resolve it. We can break the vector into two components. We also can combine the two components back to the resultant force. So we can do this is what we call this is to find resultant vector, resultant force. Yeah, the resultant force. So to find resultant force, we use Pythagoras theorem. Okay, Pythagoras theorem. Okay, now. And then we can also find direction. Yeah, actually we also have direction already. Yeah, this one. Yeah, normally to find direction we use tangent theta. Yeah, direction of this force is we use tangent theta and we use Fy over Fx. Okay, and then we do the anti-tangent. Okay, anti-tangent, the Fy over Fx. Actually, we know the angle theta already, so this direction is 30° above the positive x axis. Okay, 30° above the positive x axis. Okay, direction we can have several kind of direction. Okay, we depend on where is the vector. Your vector want to be in this direction or that direction or that or that. So we have 4 quadrant, right? So it can either in any of these 4 quadrant. So the direction, always refer to x component. We always take referring to either positive x-axis or negative x-axis. So let's put the angle over here. So how do we mention the angle? Like this, yeah. So if the vector is at the this is the first quadrant, second quadrant, third quadrant, fourth quadrant. So if the angle is at the first quadrant, so we say this vector is the direction of this vector is theta degree above positive x-axis. If the direction of this vector, we say it is theta degree below positive x-axis. Okay, so if the vector is at the second quadrant here, we say it is theta degree above negative x-axis. And if the vector is over here, the third quadrant, we say the direction is theta degree below negative x-axis. So it's always referred to always refer to positive x or negative x. Okay, above or below. So only these 4 direction. Okay, to when we want to talk about direction of the resultant force. Okay, class. But now the question is, we are only dealing with one force, but let's say I have multiple force. What should we do? Let's say an object. Okay, an object. This is the object. I push with force F1 equal to 10 Newton. It is in direction to the right, and then I have another force over here, F2 equal to maybe 5 Newton. I have another force pushing to the left, F3 equal to maybe 30 Newton, and then got another force going downward, pushing downward, which is maybe 8 Newton. So how to normally like F2 is got angle theta. Yeah, theta is equal to, let's say 20. I think just put 30 degree. So class, do you know how to find? You have 4 forces acting on a single object. Do you know how to find the resultant force? Do you know how to find the resultant force? The total force. Resultant means total. I hope that you also write notes. Write notes. I mean, you watch the video, not just watch the video. You also write some notes. Yeah, you have a notebook beside you. jotting down the notes. Yeah, because don't just listen only, because if you listen you forget. If you do, you remember. Remember, you understand, isn't it? If you just listen, you forget. But if you do to get together with me, you remember, you understand. Yeah, isn't it? So let me see. Okay, everyone. Okay, let us continue, class. So okay, how to find the resultant force? Okay, we put the x-axis and y-axis. Okay, this is the axis, x-axis, y-axis, x-axis, y-axis. Do you know how to find the resultant force? Okay, look at the notes. We have what do? We resolve. First, we resolve the vector into x and y component, and then we add x and y separately. Then we visualize the total component of x and y, and then calculate the resultant force using Pythagoras theorem, and then calculate direction using tangent theta. That's a step lah. Okay, understand? So what's the first step again? To find the resultant force, we need to resolve all forces into x and y component, and then we find the total x and total y. Understand? Total x and total y. Thirdly, we do the resultant. We find the resultant. We find the resultant vector using Pythagoras theorem. And then the fourth, we find the direction. Direction using tangent theta. That's the steps lah. That's the steps of it. Understand, class? So that's it. Yeah, that's the steps of it. Okay. So first we have to resolve the vector. Okay, let just do these questions. Resolve the vector, put into you know, the table form. Put into a table form. So I draw a table first. I draw a table. Okay. So we have, you know, this we have x component. We have y component. Okay. Wait. Let me have the table here. So this is all the forces. Okay. So here we have F1, F2, F3, F4. Understand, class? So and then finally below is the resultant force. Okay, the total F. Okay, now first you you know, direction. Going to the right is positive, going upward positive, going backward, going to the left negative, going down negative. Direction, you must put the positive negative first. Understand, class? And then next, resolve the vector into x and y. So F1 is 10 Newton. 10 Newton is to the right. Understand? It is to the right. So it is positive, but it is at the x component. So we can put it like this. Positive 10 Newton. Positive 10 in the x component, but y component is 0 because no component. Understand? And then F2, it got 2 component. F1 only got 1 component because it is on the x-axis. So only 1 component. But F2 got 2 component, got x and y. So it got x, you know, x and also y. So okay, how to resolve this F2? How to resolve F2? Remember, we have angle theta with the x-axis. So remember this one? Adjacent to the angle, we use cosine theta. Opposite the angle is sine theta. Okay, so look at this one, F2. This F2, theta is with the x-axis, isn't it? With the x-axis. So the x component is adjacent to the angle. So adjacent to the angle, use cosine or sine theta, class? Use cosine theta or sine theta? Adjacent to the angle?
Cos.
Cos. So the x component is cos theta. So we can write it as it is positive because to the right, So it is a positive 5 cos 30. That's the component x for F2, and then component y for F2. Component y for F2, the y component is opposite to the angle. So opposite to the angle is using sine theta. Okay, sine theta, and then it is going up, so it's positive. So we put it as positive at 5 sine 30. Okay, class? Sine 30 because it is opposite to the angle. So positive 5 sine 30. So we got the component, x and y component for F2. We just write it down over here, put it into a table. So this is a positive 5 cosine 30. And then for y component, it is positive 5 sine 30. So very easy, you see? F3, how about F3? F3 is going to the left. So if going to the left is negative, it only has x component, it doesn't have y component, so y component is 0. So for F3, it is you need to put the negative sign. Negative means the direction to the left. Negative 13. And then the y component is 0 because no y component. The vector falls on x component only. It only has x component, no y component. And then F4 is downward. It only has y component, so no x component. No x component, so it's 0 at x component. And going downward is negative. So we put it as negative 8. Negative 8. Okay, class? Done already. Okay, class, can someone help me to calculate? Do you have calculator with you, class? Please help me to calculate, yeah, because I don't have my calculator with me. So can you help me to calculate and write down what is the value here? Yeah, that means you help me to total up all this. Remember all this in degree. Make sure you change all this in degree. Degree, not radian. Don't use radian. All degree. Can you help me to total up 10 plus? We want to find the what is this? I want to find the total fx and total. We are at the we are at the the second step already. Just now we have resolved into x and y. We have resolved into x and y component. Now we want to find the total x component and total y component. Okay. Someone, can you please help me to total up and give me the answer here? Fx is what? Total fx. And what is total fy? Someone help me, come on. What is total fx? What's the value?
1.33.
Positive or negative?
Positive.
Positive 1.33 Newton. That's good. Thank you very much. And then how about y component?
Negative 5.5.
Got negative. Negative 5.5. 5? That's it?
Yes.
Yes. Okay, thank you. Yeah, so negative 5.5 Newton. So this is the total x, total y. And from this total x, total y, we can know the direction of the resultant already. The direction of resultant is, for x component, is going to the right. Because why? Because it is positive. And then for y component, it is going negative, going downward. It's going downward. Yeah, positive, negative, isn't it? So if we combine these two, what do we get? We get this, class. we get going to the right. The total fx is going to the right, but total fy is going downward. Going downward. Understand? Positive, negative. Okay. So this is the this is the resultant. This is the total force. The resultant force is in this direction at the fourth quadrant. Actually, the total Fy is is going this way. That's the total the total force going this way. After combining all these four forces, we get this resultant force in this direction. Understand? Okay. Which means that this is positive 1.33 and this one is negative 5.5. Okay, so we got this resultant over here, and but we don't know what angle, and we also don't know what's the value, isn't it, class? So what do? This is a triangle, remember, class? Triangle. So this Fy over here is actually opposite to the angle theta. So the Fy is over here actually, class. This is total total Fy. Understand? So to find the resultant force, we do Pythagoras theorem. Understand? So that come to our third step. To find the resultant force, resultant vector, we do Pythagoras theorem. Understand? Okay, let's do it. So that is to find the magnitude of resultant or total force, because resultant means the total force lah. Yeah, because we have you see so many force. We have 4 forces, so total up all of them. We got this resultant force. You know, to find the resultant force, this sign is, this sign is sigma, resultant. It is mean resultant. So to find resultant force, we don't do like this. We don't F1 plus F2 plus F3 plus F4 straight away. We don't do like this. We don't F1 is 10. F1 is 10, F2 is 5, F3 is 13, F3 is 13, F4 is 8. We don't do like this. Yeah. So what is the what do we get, class? Can you please add it for me? 5 plus 13 is 18. 18 plus 8 is 26. 26, 36. 36 Newton, class. Is it correct, class?
Yes.
Can we do like this? Can we just total up like that to find the resultant force? The total force?
No, sir.
No.
Cannot.
This one is only for scalar quantity. Understand? Only scalar quantity without direction, you can total up like this. But for vector, no. Yeah, this is force is a vector. Force is a vector. You cannot total up. This is wrong. But for scalar quantity, yes, you can just plus together. But for vector quantity, you cannot total up like that. Understand? So for vector, the way to write it is not like this, F1 plus F2. The way to write it is, for vector is actually like this. Total F got a sign like that. It's a vector, understand? So it's yeah, my kids is shouting, yeah. It's like that lah, because they are kids, understand? You must learn understand, yeah. Okay, so F1 plus F2 plus F3 plus F4 in terms of vector. All these signs, they are vector, understand? They are all vector. For vector, you cannot you cannot like this. You cannot like this. Cannot. Yeah, cannot. For vector, you cannot. But the way to write it, yes, correct. Yeah. F1 plus F2 plus F3 plus F4 in terms of vector, yes, you can write like this, but you cannot sum up their value. Understand? Cara menulis mestilah ada anak panah. Ini betul. This one you write like this is correct, but to total up the vector is not like this. It's not just plus together. Okay, but kalau kamu tulis macam bentuk ini F1 plus F2 plus F3 plus F4 dalam bentuk vektor, ini adalah betul. Ini adalah betul. Tapi kalau kamu tulis F1 plus F2 plus F3 plus F4 tapi tak ada anak panah, salah. Salah sebab dia bukan scalar quantity. Dia adalah vector quantity. You mesti tulis tambah dia dalam bentuk vektor. Understand? Dan untuk tambah mereka bukannya tambah-tambah nilai sahaja. Untuk tambah mereka kita kena buat apa yang kita buat semua ini. Resolve into x and y component, cari total x total y, cari resultant guna Pythagoras theorem, cari direction tangent theta. Inilah apa yang kita buat untuk tambahkan vektor force secara tambah secara vektor. Understand? We have to consider their direction. That's why we have, positive direction, negative direction, all this. Because direction is important. Because, like you see, force F1 going to the right, force F3 going to the left, they do not add up. They cancel each other. The force, they cancel each other, they become weaker force, not become a stronger force. Because the force acting in opposite direction, they cancel each other, so they become lesser force already, not a stronger force. You understand, class? So that's why we need to do the x1 component resolve. We need to find the total x and total y by considering the positive negative sign. If positive and negative, positive component and negative component means they cancel each other, become lesser force. You see. And then finally, we got the total x and total y already. We do the resultant vector, finding the Pythagoras theorem. We don't add up like this. This is for scalar quantity. Okay, so how to find the magnitude of resultant force? We do the third step, Pythagoras theorem, because it's a triangle. So we do the Pythagoras theorem. So the magnitude of resultant force is total fx square plus total fy square, because it's a triangle. Okay, someone, can you help me find the value for me? 1.33 square and then plus, fy is negative, never mind, because square already, we don't have negative anymore, become positive value. Okay, so someone please can help me to find the resultant magnitude of resultant force. Okay, what's the answer? 5.6 58. Is it correct?
Yes.
5.658, is it?
And 5.
Huh? Is it correct? 5.658?
Is 4 decimal places 6585.
6585. Oh, okay. Then it's 59 lah. We have round up. Okay. So this is the resultant force. Okay, normally for final answer we put normally lah, for final answer we put 2 decimal place. Maximum 3 decimal place maximum. Normally we don't put 4 decimal place lah. Okay, final answer, for final answer we normally maintain as 2 decimal place or 3 decimal place maximum. Okay. So that's the magnitude of resultant force, and then we need the direction. We need to know the angle theta. We need to know what is the direction of this resultant force, pointing to which direction. Remember, it is this is the we still in the xy axis, so we need to know this resultant force pointing in which direction. That's why we come to the fourth step, which is determine the direction of tangent theta. Direction of tangent theta, direction. We got the magnitude already. Because we know that vector to force is a vector. So vector has both magnitude and direction. So to describe, if we want to describe a vector, we need to give both. We need to give the magnitude and also we need to give the direction. We already got the magnitude already, which is 5.659 Newton, but we don't know yet the direction. We must give the direction. Okay, to get the direction, we use tangent theta lah. We use tangent theta. So direction. Okay, tangent theta equal to, okay. Of course, you can also do cosine theta or sine theta. Yeah, you can also do, but any way also can. Depend. But the easiest is just use tangent theta lah. Okay, so just take the fy tangent theta. Tangent theta is fy over fx. Fy over fx. Okay, so okay. So take the value fy. What is fy? Fy is we put modulus because we want to make it all positive lah. We want to make it all positive value. So we have negative 5.5 divided by fx is 1.33. Yeah, 1.33. So after modulus, it become positive lah. It become positive 5.5 over 1.33. Okay, class. So what is the then we need to find theta anti-tangent. Anti-tangent, the answer. Okay, class, can you help me to find the theta? So direction is actually theta. So what is the anti-tangent 5.5 over 1.33? Give me the angle, class. What do you get? Somebody?
76.41.
76.41 degree. That's right. And then we need to say, like as I said just now, we need to this is the vector is in this fourth quadrant, so that you need to say is theta degree below the positive axis. You need to say this all this sentence. You need to say all this sentence. Ini penting, mesti cakap ini ya, kelas. Mesti cakap ini. So you need to say it is what? 76.41. The direction is 76.41. Below the positive axis. Below positive axis. Okay, class. If you go to programming, they don't put 76.41 below positive axis. Dia tak ada perkataan below positive axis. Below positive axis, yang perkataan ini, below positive, above negative, below negative. This is our matriculation format. Our matriculation format guna cara inilah untuk describe direction. Understand? We use this. We always mention the direction in this form, matriculation. But if you want to talk about programming, kalau you nak kalau you buat program lah, you nak bagi tahu komputer sesuatu direction itu, dia bukan guna cara above positive, below positive. Dia selalu refer to mathematics. Mathematics macam mana refer the angle? It always do positive x-axis only, and then it always go anti-clockwise. Understand? Contoh lah maksudnya, maksud saya ialah kalau let's say this is 30 degree. Okay, I put all this 30 degree lah. Let's say I have all this in 30 degree. Okay, okay. So for this one, we say it is 30 degree lah. Understand? We say it is 30 degree. But for let's say this direction, it is actually 180 minus. You know, it always go anti-clockwise. So it is 180 minus 30. You get 150, isn't it, class? 150. Okay, 150. So for this direction, it is actually 150 degree. Understand? 150 degree. If for this part, you can say it is this angle. This angle. So it is 180 plus 30, which is what? Apa dia? 180 plus 30, you get what? 210. Understand? 180 plus 30 is 210. You always refer to positive axis anti-clockwise. Kalau yang this one 30 degree below positive axis, we take the big angle here. Understand? Which is what? Which is 360 minus 30, which is 330 degree. Or we can also say it, if we don't want to take the big angle, we take the smaller angle. We can mention it this way. It is negative 30 degree. Also can. If you want to tell the program, if this one, you can also say it is this way. It is you know, this is 30 degrees, so 180 minus 30, so this negative 150 degree. So what I mean is, if you take anti-clockwise, it is positive lah, positive. But if you take clockwise, it is negative. Understand? Negative. If for computer, we always go by positive, negative. If positive means anti-clockwise, if negative means clockwise. Itu dia lah. Faham kah kelas? Boleh? So itulah dia. Okay. Itulah dia. So kita sudah ada sudah dapatlah the resultant force 5.659 Newton. That is the magnitude, and direction is theta equal to 76.41 degree below the positive x-axis. Inilah positive x-axis. Itu dia. Okay? Itu dia. So haven't see. Oh, you did write in the comment in the chat room, but I didn't see the chat room, because I turned off the window of the the Google Meet, because when I record video, if I turn on the Google Meet, Google Meet also, it will cause the video to become lagging. That's why I need to turn off, and that's why I didn't see your chat. So sorry. Need you to use your speaker and tell me. Okay, anyway, let's continue. We have 10 more minutes, then I will let you off. Okay, so that's the what I explained here is the main step. It's the most important step, how to find the resultant force. It's actually the most important thing in physics in chapter 1. Because after this chapter, we always use back this thing. If you didn't master this from the beginning, you are going to have it, in the later chapter. Because we always find resultant vector. Because physics is about vector, vector and vector, and we have multiple vector acting on one object. So always we need to find resultant of this or resultant of that, resultant velocity, resultant force, resultant magnetic field, resultant this, resultant that. So you cannot run off from this. Okay, so this is the most important thing. Okay, so okay, let's look at our tutorial question. Yeah, so let's try. Okay, maybe let us try this example class. Question 7. Question 7. Yeah, question 7. So let us try this question 7. Yeah, and then we can that's all for today. If once we did question 7 tutorial. Okay, so take this picture. Okay, that's it. Is it clear, class, this one? Yeah, boleh ya?
Yes, sir.
Okay, thank you. Okay, I'm still recording. Yeah, am I recording my sound? Yeah, it's turned on. Right. Okay, so we have three forces here. I need to find fx, the sum of components in x component, and then we need to find the sum of forces in y component, that is fy, and then we need to find the magnitude and direction of resultant force. That means we need to do Pythagoras theorem. Finally, we need to do tangent theta and then anti-tangent to find the angle theta, above or below the positive axis or negative axis. Okay, so let us do it. Yeah. So first of all, don't forget direction to the right positive, direction upward positive, direction to the left negative, downward also negative. Okay, so we can resolve the forces first. Understand the steps? We always resolve the force into two component. Okay. So for F2, it also got two component. Yeah. And then got for the for F3, F3 also got two component. Okay. And then we need to all in the table form. Table is a systematic way to gather the information. That's why we need tables. Okay. Systematic. Yeah. So we have forces put here, x component, y component. So we have F1, F2. Somebody prepare your calculator, ready to get me the value, class. Ready to get me the value, because I don't have calculator with me here. I have calculator, but all thrown, all destroyed already by my kids. They throw things here and there. So rosak lah. Okay, so F1, so fx and fy. Okay, so let's look at F1. F1, so what is the fx? Okay, fx is positive, so we put positive. We put positive. So it is positive, because going to the right, positive. 8 Newton, cosine or sine? Cosine theta or sine theta for x component? Cosine or sine theta? Adjacent.
Cos.
Cos. So it's 8 cos 30. And then for y component is opposite the angle. So y component is sine theta. So is going up. Going up is positive. Going up is positive. Positive. 8 sine 30. That's it. We done it. F2. Now F2. F2, the angle is y component. You see? The angle is with y component. So the y component is adjacent. Y component is adjacent. It's going up. Going up, so it's positive. So let us do the y component first. So it's going up. So positive. It is 6 Newton. So 6. Because the y component is adjacent to angle. Y component is adjacent to angle. So it's cosine 40. Okay? And then the x component is opposite to the angle. See, look at here. The x component, you see the x component? is opposite to the angle. So the x component is sine 40. So it's negative because going to the left, negative. So you need to put a negative sign, negative 6 sine 40 because it is opposite the angle. Okay. How about F3? F3, okay, you cannot see the angle. It is 55 degree, yeah, 55 degree. So what's the angle? Okay, the x component is adjacent to angle, so x component is cos 55. Correct, not class? And it is to the left, going to the left, so it's negative also. So it is negative, going to the left, negative 5 cos 55. 5 cos 55. 5 cos 55. Okay, correct kan? And then the y component, it is opposite to the angle. You see the y component? Y component is opposite to the angle. The y component is opposite. So it's sine 55. It's going down. It's going down. Going down is negative. Going down is negative. Negative 5 sine 55. Okay? We done it. Negative 5 sine 55. So, okay, so total up. Somebody please help me. Total up. The S component total up. What do you get, class?
7 point.
Cannot hear your voice very. Never mind, you just type in the chat room. I now I can see. What's the value? Just type in the chat room. What's the value? Or you just tell me lah.
0.204.
0.20.
0.20. 0.20, is it? Or 0.36? Okay, good. And then total got is it positive or negative, class? This one? Fx positive or negative? Positive,
Negative.
Yeah. And then for Fy, what's the value? Fy
4.50.
positive also,
Yes.
4.50, is it? 4.50, so this is a force. So all of these are Newton, Newton. Okay, so both of these are positive value, They are all positive value. That means they are going. The direction is going to the right. Fy positive means going upward. So the resultant force actually is going this way. Understand? Going this way. That's the resultant force. Let me just write another other place. So that means it is this way. Fx and Fy. Total, this is total Fx, this is total Fy, because it's positive x and positive y. So our resultant force is this one. This is our resultant force. Understand? So we need to find the angle theta later. So we need to find Pythagoras theorem. So Pythagoras theorem, total F. Salah. Total F, Okay, total magnitude. We find the magnitude first, magnitude of the force. Later we find direction. Okay, so the magnitude is total Fx square plus total Fy square. So what do we get? Somebody help me, class. So 0.2036 square plus Fy is 4.5. So class, help me, class. Berapa? And then to find the direction now, to find the direction, some
4.50.
4.50 also, Okay, thank you. because the x component is extremely small. X component is extremely small, so majority is y component. So actually the direction is more to x component is so small, so it's more to this way lah. Yeah, the resultant f is actually like this lah. So you can imagine the angle theta is near to near to 90 degree. Maybe 89 or 89 or 0.99 something. Yeah, maybe lah. Okay. Later we check out. So the resultant f the resultant the resultant force is almost here. Okay, so this is the magnitude of resultant force F. So find the direction theta. So find the direction theta. So now I want to find direction. So direction we use tangent theta lah. Tangent theta equal to total Fy over Fx. So which is 4.5 over 0.2036. This tangent theta. So now later on I need to anti-tangent it. So what do I get, class? Can somebody help me, please? Anti-tangent, you divide this and then anti-tangent, what do you get, class? '87, 87.41 degrees. See, so it is near to 90 degree. Yeah, 87.41 expected. Yeah, above positive x-axis. That's it. Above positive x-axis. That's the direction. So these two, okay. These two, magnitude, direction. So complete. We got the vector, the resultant vector F, resultant vector force, resultant force vector. Understand? We complete to get a vector. Okay, answer. Vector must have magnitude and direction. Okay, that's it. So that's question A is sum of force in the x component. So for question A, that's the answer for question A, and question B, that's the answer. Yeah, for question B. Yeah, that's the x component, total x component A, and this is the total force for y component, 4.5, and then magnitude of resultant force, that is this one. Yeah, Pythagoras theorem. This for question C. Magnitude and direction. So we have both magnitude, 4.5. Direction is 87.41 degree above positive axis. So we have magnitude and direction of the resultant force. Okay, so that's it for this this part. Okay. All right. So okay, so for other question, I will discuss again in our tutorial class. Okay, right now maybe I give you one homework. Yeah, just one homework for you. Okay, you need to do one homework. Okay, so this is our lecture note. Lecture note has many good questions. Yeah, maybe you can try to do this question for me. Only the one question, okay? If you have extra time, can do other example. So lah, example 4 and example 5. In page what? In page 7. In page 7, okay, page 7 of lecture note, page 7, you can do all the question lah, 4, 5, 6. But I personally choose this question lah. If you don't have much time, you can at least do this one question for me. Example 6. Yeah, example 6. I want to see, yeah, in your next class, I will check each of your work. I want you to see you do this question. Find the resultant force of all these forces. Okay, resultant means you need to give both magnitude and direction. You need to resolve x. You need to first resolve the forces into x and y component. Put it into the table. Remember the positive, negative sign for direction to the left, to the right. Pythagoras theorem to find the resultant, and tangent theta to find the direction. Okay. So I leave example 6 as your homework for you. Okay, that's it. That's it for today, class. Any question, class?
No, sir.
Okay. Okay. Clear. Okay. Okay. Thank you so much for today's lesson. I will upload this video recorded into YouTube lah, so you can rewatch any part you don't understand. Yeah. There are many other video also in the channel already. Yeah. So you can also watch if you are interested. Okay. Also, if you are find it helpful, you can recommend it to your friends lah. Okay. Maybe if they need it. Okay. Thank you very much. Okay, and good night.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay, thank you. Don't forget, tomorrow afternoon we have this for innovation competition briefing. So please come lah, yeah. Tomorrow at 2 o'clock, DK6, DK6, yeah. Come for the briefing. Then you have an idea what kind of innovation you can create. Okay, because this is very good for your university application in the future. Okay, you must at least be active in your co-curriculum lah. Okay, besides the academic. Okay, that's all for today. Okay, thank you. Bye.